Welcome back to our video module on mechanics of materials. Today, I'd like to revisit our relationship between axial stress and strain and shear stress and strain. As I look at these two diagrams, I get the feeling that somehow there's more to these two equations than meets the eye. I can feel that in both cases, we're somehow stretching a particle horizontally. And today, I'd like to play with that relationship. So for instance, let's take our shear diagram, redraw it right here. And I know that I have some sort of shear stress. I'd like to redraw that as a composite of a vertical and a horizontal stress. And what happens is if I do this for each of my shear stresses, basically just putting them into components, I see that in the vertical direction, check this out, these are equal and opposite.
If we wanted to be truly accurate, we'd see that by separating these into composites, we are left with a horizontal stress and a vertical stress on the element.
The resulting stresses that I'm dealing with are some sort of axial stress in the horizontal direction. Well, this looks just like what I see here. Let's see if I can think of it another way. I can also think of it as if I have some sort of beam. And when I apply a force in the x direction, I can imagine I have a little particle like this. I have a stress, and as a result, I have some sort of strain in the x direction. Likewise, I have another beam, just like it, vertical force, but this time, instead of orienting the particle like this, I'm going to orient my particle like this. And what do I see? I see a distortion. I see a distortion like this, of course exaggerated, right? And I still see some sort of strain in the x direction. But in this case, this is coming about because of shear. So I want to believe that there's some sort of relationship between these two. In the former case, we're talking about axial stress, and that will be governed by the Young's modulus. In the latter case, we're talking about shear stress and shear modulus. In fact, there is a relationship between the two, and that is the shear modulus is the Young's modulus over 2 times 1 plus the Poisson ratio. In summary, these three material properties, the Young's modulus, shear modulus, and Poisson ratio, are intimately connected. In your problems, if you're given two, you can find the third, and in actuality, in real life, often we have two, and we use those two to find the third. I hope this video gives you a snapshot of the relationship between the moduli of materials. For right now, we're going to take the 50,000-foot view, but at a later time, we may take a closer look at the nuts and bolts of this relationship and how we get to this equation.